Gracias por venir a este formato de las Thursday Nano-Spin-Off Talks, que de momento va a ser un formato pues así online, en streaming. Lo primero que quiero hacer es pues, contaros un poco la idea de este ciclo de conferencias que está patrocinado por la Cátedra Sanca de Nanotecnología de la Universidad de Zaragoza, de la cual soy directora. Y la idea de este ciclo ha surgido porque queríamos contar cómo son las empresas de Nano Spin-Off desde varios puntos de vista. Lo queríamos contar, pues lo primero que está puesto ahí, los últimos jueves de cada mes, para que tengáis fijo y que sepáis cuándo va a ser. Obviamente, el de diciembre de Navidades no va a haber conferencia, pero los demás sí que habrá una conferencia a las 6 de la tarde los últimos jueves de cada mes. Espera. Ay, disculpe. Vamos a... Hay otra persona en la sala que está suficientemente lejos. Como os decía, lo que os quería comunicar es cómo son el formato de estas conferencias y cuál es el objetivo. Buscamos empresas spin-off que tienen su tecnología basada en nanociencia, en nanotecnología. Queremos empresas y va a haber empresas que nos den las charlas, que van a ser desde empresas pues, más recién nacidas, que va a ser el caso de hoy, ya que está recién naciendo así este ciclo, hasta empresas pues, mucho más maduras, que hace 12 o 15 años que se fundaron y que han llegado a algo mucho más, para que tengáis una visión amplia de lo que puede empezar en un spin-off y dónde puede acabar, y tengáis toda la historia. Además, por supuesto, queremos mostraros empresas que vengan de distintos ámbitos de la nanotecnología, pues tanto en aplicaciones bio como aplicaciones físicas o aplicaciones de comunicaciones. Ya sabéis que hay muchas aplicaciones de la nanotecnología. Y el objetivo también es que conozcáis no solo empresas que sean españolas, spin-off, sino también pues, internacionales en general, pues empresas europeas. Vamos a invitarlas para que vengan a darnos la charla, que también es el caso de hoy. Ahí os pongo pues, los tres ponentes que ahora mismo están confirmados. Sara, que va a hablar hoy, ahora vamos a presentar. Borja Barredo, que es de una empresa española, Microfluidics, y André Pereira, que es de otra empresa portuguesa y que es Nanotechnology. Como veis, hay de distintos ámbitos y todavía más que nos quedan por confirmar. Bueno, pasamos a presentar a nuestra ponente de hoy, que es Sara Abalde. Hola, Sara. Entonces, pues Sara es investigadora en el Instituto Nacional International Liberian Nanotechnology Laboratory, para que no me equivoque, en Braga, en Portugal, en el norte de Portugal. Y, por supuesto, pues, ¿qué tiene que ver con la spin-off? Pues ella es la Chief Technology Officer y cofundadora de la empresa Rubí Nanomed, que fundaron en el año 2018. Como os he dicho, algo pues, bastante joven. Ella trabaja en el grupo de investigación de diagnóstico médico con sistemas microfluídicos, ópticos microfluídicos para la detección, que os lo va a explicar ella pues, mucho mejor que yo, para la detección de células cancerosas utilizando la espectroscopía Raman. Sara hizo su tesis doctoral en la Universidad de Vigo, que terminó en el año 2013. Después de allí se fue a la Universidad de Cambridge durante 2 años. Luego de allí, ya sabéis que los investigadores vamos moviéndonos, y luego de allí se fue a donde está ahora mismo, en el Instituto en Braga. Ha recibido numerosos premios, tanto por emprendedurismo como por su investigación. Tiene 23 contribuciones, tiene una patente. Luego, no es solo que tiene numerosas, ha sido conferenciante y conferenciante invitado en muchas conferencias, y no solo que divulgue la ciencia y que cuente la ciencia que hace, sino que además está intentando aplicarla a la vida real y que esto tenga un resultado en la sociedad. Y eso fundamentalmente es de lo que nos quiere hablar hoy, para que veáis cómo es eso de una spin-off. Yo no tengo nada más que deciros, que la verdad es un honor. Ella desde el principio os ha mostrado súper dispuesta a dar la charla, todos los cambios que le hubiéramos pedido, da igual en formato online, el tipo de formato que sea. También le hemos pedido, porque también parte de los estudiantes son internacionales y tenemos estudiantes del máster de nanotecnología, que diera su charla en inglés, así que la charla va a ser en inglés. Pero también, por supuesto, porque como es española gallega, le podéis hacer preguntas en español, os va a contestar también sin ningún problema. Otra cosa importante también que os tengo que decir es que, como queremos que estas charlas queden aquí y se puedan seguir divulgando, vamos a grabar esta charla. Entonces, si alguien tiene algún problema en que su imagen aparezca, pues puede apagar las cámaras y no aparecer nunca, o si no, pues aparecer. Otra cosa importante también para tener una buena calidad del sonido es que, por favor, apaguéis todos vuestros micrófonos y, pues, cuando tengamos un turno de preguntas, en ese caso, pues, encender el micrófono. Y con esto, pues, os dejo con la invitada de hoy, con Sara Valde. Muchas gracias, Sara.
Gracias, Reyes. Muchas gracias. Aplausos virtuales.
Aplausos virtuales, exacto.
Okay, so I'll try to share my screen. Okay, I suppose this is working now, right?
It's working. Great.
Good. Thank you. So thank you very much for the introduction. Thank you very much for the invitation. I really feel humbled to be able to show my little experience, and I'm hopeful that I can inspire somebody to follow the path of innovation. So I wanted to entitle my talk "Emprendiendo, ciencia y aprendiendo innovación." Right? I will try to do the translation like science, entrepreneurship, and learning innovation, because I think that we need to actually exchange this concept, right? Because we usually learn science and we do entrepreneurship through innovation, but we have to also bring a bit of entrepreneurship to science to be able to learn how to innovate, how to bring what we do in the lab and what we do at universities and research institutions to the use of the society, right? Because that's what we all would like. So Ray just introduced me very well. I'm Galician. So I did my PhD at the University of Vigo. I will just give you just a brief introduction about myself so you can put things in perspective. Why is Sarah doing these sorts of things? So I'm a chemist. I'm a chemist by background. I literally flipped a coin. I didn't know whether to do biology, chemistry, or whatever else related to science. So chemistry was the choice, but I did my PhD in physical chemistry and in nanotechnology more specifically. So I developed different kinds of sensors to do detection of contaminants in water, contaminants in air, and also allergens and some proteins. Apart from that, doing the PhD in Galicia is much fun because you can drink albariño and have seafood as much as you want. So after that, in 2013, I moved to the University of Cambridge. This is a beautiful place. You should visit it sometime when it's possible. Apart from being a beautiful place, it's a place that you feel constantly motivated and you learn all the time. Even going to the pub, having a beer, you can have a very inspiring conversation about the things that you can do, with the things that you are doing in the lab, right? And you're surrounded by people that is constantly moving and looking for something new. So in there, what I did is microfluidics. So if you haven't heard about it, microfluidics, it's a sort of technology that deals with liquids in the microscale. So we confine liquids, we put them in very tiny devices, and so that we achieve miniaturization, automation, high throughput, and all these very nice adjectives that we are looking for when we are developing sensors. So what I did then is I wanted to combine my two main expertises, related to nanotechnology and to microfluidics to bring it to a real application, because all my work before was fundamental science, which is great and is highly needed. But I wanted to explore a bit more the boundaries. So I did apply for a fellowship to be working at the International Liberian Nanotechnology Laboratory, very long name, Regis, that's true. And in here, this is an institute that is fully dedicated to deploy nanotechnology into society in different fields, in the field of health, in food, energy, ICT, and many others, and then the interface is among them. So this is a facility that is quite impressive. It was built with money from Portugal and Spain, from those governments when they agreed back in 2009, I think. Yes, 2009. And this is a state-of-the-art facility that you are very much welcome to come and visit. You just need to pop me an email and you can come and visit. And if you want to know more, you can ask me. But today we're not going to speak about fundamental science. I would like to speak a bit more about innovation. And so I would like to share my view about innovation. Uh, but again, I am quite new person in innovation, in startups, in spin-offs. My first contact with this world of startups was in 2014, actually in Cambridge. And I started learning what innovation is, and you can find many definitions. And I would like to be now with you in the same room, because we could have a nice discussion, but I guess you will have to just listen to me for 45 minutes in a row. So my view on innovation, and it's that it's continuous in our lives, right? So if we are at the kitchen cooking and we break a tool and we need to do something and we can't open the chestnut, then we will find something else to open the chestnut, and that's innovation. You have a problem, you look for a solution. And then in society we have problems that the solution is not as straightforward, right? So we need to put our minds together and our scientific knowledge to find solutions for things. Then other people would argue that there is another layer of innovation, and I think that's quite interesting. This other layer, which is, it's not only when there is a problem and you offer a solution, you can also create a sort of problem or need, even better, a need in the society. And so you have to provide a product or a service to cover for that need. And that is also the way we understand innovation. So I took the chance, because I'm the first one of this series of seminars, of just dropping some keywords here in case you have no experience with innovation or with the startups or whatsoever. But I will try to be quite short. I'm just aiming at dropping keywords, and then you could remember, like in a month's time, oh, this person that spoke in this seminar, she mentioned something like this. Maybe I Google this keyword, and then you find the information. So I spoke about problems. So when we want to innovate, we have to identify the problem that we want to solve. I might just start introducing the problem we are aiming at tackling in my company, in Ruby Nanomed, which is cancer sensing and cancer monitoring. That's a huge problem. I don't have to go into it, because we all unfortunately know that problem. There are many different problems associated with cancer that we can identify, right? The efficacy of therapies, that we need early diagnosis to be able to do prevention, and all those sorts of things. In my case, I dedicate my efforts and the efforts of the company to do a tool for diagnosis and monitoring of the evolution of cancer. So that's my problem. And then you need to have an idea, right, on what am I going to do to solve this problem. So if you at any point sign up for an innovation program and an accelerator program, or so on, you're going to be listening in the first classes, let's say, and seminars about the problem, the solution, the idea, and all these concepts I'm going to tell you. I went to several acceleration programs in Cambridge, here in Portugal, also in Spain, and to an intensive one of 2 weeks in Boston. and it's always around the same concept. So if you have the clarity of mind to identify these things, then everything is possible. So we have a problem, we need to have an idea to provide a solution. And because we are scientists, we are all the time looking for solutions. So that's easy on our end, right? And then there is something that comes into play, which is how orthodox you can be. And this, to me, it's important, and it's not often mentioned. We are scientists, and so that we tend to have quite an analytical mind, and we tend to be very orthodox in the lab, and we should be orthodox and we should be systematic. This is extremely important when you do innovation. It's even more important than when you're in the lab, because then you're gonna want to sell something to another company or to customers, to patients, to hospitals, to whoever, and you want this thing to work. And so you have to be very orthodox in your methods. You have to be very systematic, and everything has to be validated in the right way and at every single step. Because if you haven't been orthodox in one step and then you have to go back that step, that can cost you millions. And we know that getting millions to fund science, it's very challenging, especially in Spain, especially in Portugal, and in other countries that they are not as wealthy as countries from North Europe. I mean, let's just be honest and say it. Why not? So this is also super important because in the last years, there has been a struggle for scientific startups because there has been a loss of credibility in science among investors, among people with money, with those millions that we cannot get from governments, that we cannot get from public funding, to bring these ideas and these solutions in a fast pace to society, right? And this problem and this loss of credibility, I have noticed it a bit when talking to investors, especially in America, because there was this big scandal that you might have heard about, and this is where orthodoxy comes into play. So there was this company, Theranos, and Theranos was, some of you might have heard about it, was a big scandal a few years ago. So Theranos was selling that with a single drop of blood, they could do all sorts of analysis of your blood, whether you have cancer, diabetes, tuberculosis, all sorts of diseases. This was put together so well, but only in terms of marketing, only in terms of communication, in terms of networking, in terms of Elizabeth Holmes, which was the Theranos CEO, to be able to convince people about her idea, about her product, but the product didn't exist. Theranos was invested $9 billion. This is a huge amount of money. And there wasn't a product and there wasn't anything. And she actually went to court. So now people are struggling to invest into science because they need, if 5 years ago before Theranos scandal, they needed, small proof of concept with 10, 15, 20 patients was enough, and they would invest in you a few million euros if in Europe, 10 orders of magnitude more if you're in America. Right now, you have to do that with 100 patients and not with 10 or 15. And that costs a lot of money. So you have to be orthodox and honest. And it's usually very difficult for scientists to be orthodox and at the same time to pump a bit things up, right? Because we still need to do the marketing and we need to convince people that our thing is good and is the best. But in the mind of a scientist, at least in my mind, and I believe that in most scientists, we want to do all the controls, we want the things to work perfectly before we are confident enough to even thinking about bringing something into the society. So this balance for me and for my colleagues in the company, in all the previous spin-off projects I had, that was the challenge, to trust enough in your science and to speak the language of entrepreneurship and the language of funding, the language of investing. So if you have that great idea, what do you have to do first? Well, protect your intellectual property, go for patents, go for secrets, for trademarks, all these things. There are immense seminars online, especially now that they're for free, that you can attend if you don't know much about patent applications. You don't have to write a patent. I mean, you usually have to write a patent yourself, but then all the filing, administrative things, it's usually done by your institution. So don't be scared. You have to write it. You read some patents, you write it, and then they will help you from the law firm that the university or the technology transfer office of the university has, or your institution. But protect it. To protect it, you can't you can't do a publication before the protection. You can't go to a conference before the protection. I apologize if I'm telling things that part of the audience is aware of, but I know that there are many master students here, so I just want to give you those tips. It happened to me 3.5 years ago. That I had this, not the idea for this company, but another patent that we will be willing to incorporate in the company. And I wanted to go to a conference because they invited me, and my boss said, Sarah, you have to go to this conference, you have to present this. And then I was like, oh my God, but now if I go to this conference in 2 weeks' time, I won't be able to submit a patent. So we did a patent in 2 weeks. So you can do it. It's important. You just need to press the right keys, talk to the right people, and so on. And you can do it. I am very shy, but you can do it. You learn how not to be shy. So just go ahead and knock the door of people and do it. Then what you have to do, you have to validate it. Of course, you have to test it in the lab, you have to develop a proof of concept, and that thing has to be robust and it has to work. So you don't have to validate it if we're talking about sensors for cancer, for example. You don't need to validate it in 100 patients to create your company, but you have to validate it in a few patients, and it has to be robust. Then what they're going to tell you if you get enrolled in an acceleration or innovation program, what your mentors are going to ask you for is, did you speak to your customer? Did you do interviews to your customers? And then that's where, the first time they'll tell you is like, yeah, I mean, I want to sell these to hospitals. Oh, but did you speak to the hospitals? Well, I spoke to other scientists and I read papers and they told me that this is great. And they're going to say, no, you have to go to the hospital, you have to speak to the doctors. And so you go and you speak to the doctors and you speak to 20 doctors that tell you, oh, this is great. We want it here. And so you start developing the things. But then when you start reaching higher levels, they're going to say, yeah, but you're not going to sell it to the oncologists. The oncologists are not going to buy the machine that you're going to put in the hospital. It's the hospital administration who is going to buy your machine. And you have to take into account a million things that you were not aware of. And that is, again, why it's important to speak in this case, not with the lawyers as when the patent protection, but in this case, to your customer, being another scientists, because you want to develop maybe nanoparticles that are able to recognize or to be functionalized with a protein, and you can sell that to do lateral flow assays to labs. Fine, speak to the biologists that are going to use these. Tell them if it's easy, tell them if they want a kit, tell them if they want to know about what's on top of the particles, or they just want 2 milliliters of something that you tell them mix this plus this, and then you're gonna get this. Or if they want to know that. So you have to always speak to your customer and do a survey on who is going to be your user. And then you have an idea, assess the market, right? Because maybe just your customer is going to say, oh yes, this is great, I want this sensor that can detect at home when I am going to be sick in 1 week with flu. Yeah, but maybe in the market this is already done. and you have an idea, but what's in the market is much faster, it is cheaper, or there is a lot of competition. And so that will be very difficult for you to bring your product and compete with high companies, for example. So that's something to take into account as well. Then there's something else that happened to me when I was a bit more naive than now. I'm still very naive. That on the first acceleration program, and we said, oh, we have these particles that we're synthesizing, and we're gonna sell it, and these are very special particles because they can't do this. And the mentor told us, so who's your competition? And we're like, oh, we have no competition. There is no company doing this in the world. And they were like, oh, well, then I don't think this is good because you don't have, there is no market for you out there. This is still not the need. And for a very young startup to create a need in society, it's extremely difficult. So you have to assess your market, and then the market has different layers. I don't want to extend on these because that these are hours and hours of experts explaining these things, and I'm not an expert on the market evaluation. But there are different layers. So you in cancer you have the cancer market, but then in cancer, are you working in diagnostics or in therapeutics or in diagnostics? And then in within diagnostics, are you working in early diagnosis, or are you working on monitoring? That market is going to be different, and you have to identify in which, where is there a gap in the market that you can feed in your idea, right? Or where is there a gap in the market? Can I have an idea for that gap? So these are a lot of things to think about when you're trying to start something, to bring your idea to something concrete, something real, to create a company. This is something that summarizes basically all the things I said. I'm sorry, this is in Spanish. But this is what's called a canvas. That's the first thing they're going to give you in an acceleration innovation program. They have stopped slightly showing the canvas. There are other ways now, but it's useful at the beginning. It was a nightmare for me the first time, like, oh gosh, this is crazy. But some things that I already said, right? So your value proposition, what are you offering to the market, which is the center of everything. Let's say if I can do pointer, yes. So what are you offering? And then there are all the different things that you have to take into account. So who's your customer? So your segment of customers and users, but how are you going to relate, to communicate these to your customer, and how are you going to get to be known? I mean, I'm a scientist, I publish papers, I go to conferences. I mean, and we are talking about speaking to companies of the size of Roche, Merck, Bayer. You want to present, you want them to be aware of your technology. How are you going to make those people know you? Or the hospitals, how are you going to reach them, know what you have? But in terms of resources, how many people do you have? How much funding do you have? How much funding do you need to do what you want? Etc., etc. So this is something that might seem very complicated at the beginning, but if you go to a few acceleration programs, that's enough to understand this, and then to just make yourself comfortable with all these things. And it's important to get into your team people that is motivated and that also is aware of some of these things. So I mentioned some of these keywords, networking, but not networking in the way we do in a scientific conference. The networking is much more aggressive. The networking has to be much more confident. You basically have to be very blunt, and you have to go speak to people. The networking you do for implementing nanotechnology based solutions to be applied to health is going to be in health fairs, where you're going to have all the big companies that sell these things, so they might acquire your technology at some point. So this networking is slightly different. It's also very much based on marketing. So we need to flip the way we do the networking if we want to do that. Pitching. I'm going to try and do a pitch for you about our company. It's going to be a long pitch because I want you to understand what we do. But this is the famous elevator pitch, which called the elevator pitch because they went into an elevator and it was in a. I mean, I always forget about these sort of about the details of these stories, but it was basically two people going into one of these super big buildings, and there was like 20 different 20 flats, and it was 2 minutes, and in those 2 minutes one sold to the other the company just by pitching. That's why it's called elevator pitching. You have to, in 2, 3, 5 minutes, depending on the program, depending on the place that you go or you apply for, you have to catch the attention of the people that is going to invest in your company or that can buy your company or that can help you to develop your company even more. Business model. So business model, I mean, there are so many business models, and the business model is not something that is static. It's something that changes. It's very dynamic. So we, in this company, in Ruby Nanomed, we started thinking that we could sell our technology as a service, meaning we have some sensors and we process the blood of cancer patients. I'm going to explain more about it in a bit. So what we thought is we can just receive blood of cancer patients and process it in the lab and give the results. But then we did pivot, which is a word that they use a lot in the entrepreneurial arena. We pivot because usually a business model as a service for these kind of things, it's not scalable, meaning, yeah, you can probably get a lot of customers, but there is going to be a moment in which growing is going to be very difficult because you will need a lot of people, and it's not something that you're going to sell. It's not a product that you can keep scaling up your business up and up and up. So many different business models. I'm going to explain mine in a bit, ours in a bit. And then the go-to-market strategy. How are we going to reach the market? Who are the people, the doors, the companies, the stakeholders that we have to reach in order to get our product into the market? So for science-based startups, which applies for nanotechnology-based startups, just a bit summary, is that it's important the IP portfolio. Maybe 20 or 25 years ago, you could get investors to invest on science without having patents. Now, one of the first things they ask you if you have a patent, otherwise they do not take you very much into consideration because there's nothing they can protect, because they will have a technology that can be copied at any time by anybody. So there's no protection of your technology. That's a validation and credibility. We said it's very important for science-based technologies and startups, and the credibility, it's important in terms of the networking. It's not the same. So now, our company is in Portugal, and we have the collaboration of amazing oncologists. The most well-recognized oncologists in Portugal. We also collaborate with oncologists in Spain, which are leaders in the field of liquid biopsy in Europe. But unfortunately, it's not the same saying we collaborate with this oncologist in this hospital in Spain or in Portugal or in France, rather than saying, I have the oncologists from the Mass General Hospital in Boston testing my device. And this is how it works. And we know it's unfair and it shouldn't be like this. But it is how it works. And funding and entrepreneurship and investors, they still very much rely in these sorts of influences, let's say. So you have to take it into account as well, and you have to reach powerful people. build up on your team. This is the most important thing. I mean, you can't have a company with people you don't trust. You can't have a company with people you don't admire, and you can't have a company with people that you don't think they're excellent. So this is set by some to be the most important thing when you create a company. By some others, it's the timing, and I can never decide which one is the best. The timing is, maybe you have an idea for something today in 2020, which is an amazing idea, but there is no market for it, so it's not the right timing. And maybe if you had the same idea and you implemented that in 2030, then that will be an amazing idea and you will make a lot of money. So the timing is also very important for that. Then there is something quite curious that I found out, is that, hey, apart from all the things I said, that, hey, stop thinking like a scientist. No, stop thinking like a scientist all the time. But you're still a scientist. So when you go and talk to investors, explain science, educate them. They need to know what we do. They need to know how it works. They need to know what it is for. And they very usually like to see a person that is very passionate about what they do. So explain them what you do. And this is different in different countries and in different continents, because in Europe, investors tend to be more money oriented. They want you to tell you in 2 years you're going to make millions. In America, I was expecting the opposite, but what happened is that when we went, we were questioned all the time about the science behind our technology, and that was a very different point of view. So we in Europe, we still need to educate a bit investors and to talk about science. If you do it with passion, they're going to be thrilled. So, and now expect longer break even. What is the break even? I mean, the break even is when you start having benefits in your company. So there is something that I faced in some acceleration programs that were not very specific for science. They were generic. So there were startups dedicated to science, which it was me and another couple of startups, and then the 80% or 90%, it was e-commerce, it was digital startups, it was fintech startups, financial technology startups. So, I mean, of course, I would get to the pitch and I would tell them, hey, in 5 years, we're going to make 20 million with my startup. But then the other people, they get there and they tell them, oh, in 6 months, you're going to make 5 million. So the break even is much longer. If you go to generics, you speak to generic investors, you go to a generic accelerator program, you're going to be competing with people that can offer benefits much faster than you. So you need to go to places that they're already a bit used to have this conversation with scientific-based startups. Otherwise, it can be very, very frustrating, because it's impossible to bring something to a sensor, something that you have to do clinical trials with in a fast pace. We all know about this now with the vaccine, right, of coronavirus, and we are being well, people developing these, they are being extremely pushed, and still we will need months and months to develop it. So this is not how it works. We can't offer benefits in a few months, and you don't have to make up your numbers, you know. Your numbers are your numbers, because it's a scientific based startup. So don't fall into the trap of, oh yeah, in 1 year, maybe we can do it in 1 year. No, just you have to do it well. And if it is the right investor, it will understand that, and it is what is called smart money. Because maybe you meet one of these busy angels, which are people with a lot of money that they become spur like this. So maybe you go to Parte, you meet one of these busy angels, and they tell you, oh, I'm going to give you this 2 million because I have to invest, because then I have benefits when I do my taxes at the end of the year. So I have to invest this 2 million. I'm going to invest it in you. Well, you have to think about it. Is that, because that's not smart money, and that person is going to be pushing you, and is not going to mind about your science in most of the cases. and well, regulations. Obviously, if we're talking about somebody that develops nanoparticles to sell for whatever application, you need to have certification, you need to have homologation, and if you go for clinical trials, you need to have in the US FDA approval. Here in Europe, you need to have clearance from the European Union as well. So I know I spoke a lot about these things. Might be very basic for some, might be very new for others. Some others might thought that I spoke a lot about a lot of things, but my goal was that at least you have some of these things in mind, and hopefully with some more talks in with the next seminars, you can sort of do a bit of tidy up in your brains with this.